Alright guys, so today we're going to do another lesson like we did a couple weeks ago through Edpuzzle, and I will send these notes out to you through Google Classroom so that you have this if you want to print it out before you do this. But what we're going to be discussing is how to simplify rational expressions, and in order to do that we're going to need all of the skills that we've been practicing involving factoring polynomials and solving equations using factoring. So at first, we're asked to determine which values of x would make the expression undefined, and which values would make the expression equal to 0. So we have two expressions here, and before we look at either one of them, I just want to take a look at what would make a fraction be undefined, or what would make a fraction be equal to 0. So if I had a fraction that was something divided by 0, this would be a problem because logically you cannot divide something into 0 groups. You can't have 15 apples and divide them into no groups at all. You can divide 15 apples into one group, or 15 apples into 3 groups, or even mathematically you could divide 15 apples into 3.7 groups. But what you can't do is divide 15 apples into no groups at all, because that doesn't make any sense. So that we would call undefined. Because this just can't be done. There's no logic behind dividing something by 0. However, if I have 0 in the numerator and I divide it by something, that's a different story. That's saying I have no apples and I want to divide those 0 apples into 1,000 groups. Well, that's fine, but you're still going to have 0 in each of those groups. So if you take 0 and divide it by anything, you'll get 0. And those are the two cases that we're looking at here. So when we're talking about when a fraction is undefined, what we're saying is when is the fraction's denominator equal to 0? And when we're talking about when is the fraction equal to 0, well, that's just going to happen when the numerator is equal to 0. So let's investigate undefined here. And when we investigate this fraction to determine where it's undefined, all we're going to do is set the denominator equal to 0. And now we have to figure out what x would be in this case. So subtract 10. I'm left with 2x equals negative 10. And then I still have to get x alone, so I'll divide by 2. So this fraction is undefined when x is equal to negative 5. When is it 0? Well, it's 0 if the numerator is equal to 0. So I'll investigate that. When is it 0? And in order to investigate when it's 0, I'll just have to take the numerator, set it equal to 0, and that's a much simpler equation to solve. And x equals 0. So this is what we've learned. In this particular rational expression, if your x value is negative 5, then this expression will end up being undefined, because negative 5 times 2 would be negative 10, and negative 10 plus 10 would be 0. So we would end up with 0 in the denominator, which creates an undefined expression. If the x turns out to be 0, though, the denominator will be fine, because 2 times 0 is 0, and 0 plus 10 is 10. So it's not undefined, but the numerator is going to be 3 times 0, which is 0. So that would create a situation where the whole expression is 0. Let's do the same thing over here with this second expression. I want to investigate when it's undefined, and I also want to investigate when it's 0. So I'll set this up. It's undefined when the denominator is 0, so x cubed minus 16x would have to be 0. And now I'm going to let you solve this. The video will pause. Go ahead and figure out when it is that this expression is undefined. So now I'm going to solve it. In order to solve this, I'm going to have to factor. This is just like solving equations using factoring. So I'm going to factor out a GCF, which in this case is x. And I can continue to factor using difference of perfect squares. So I end up with 3 factors, and remember when we're solving, we now have to set each of those factors equal to 0. So x is equal to -4, 0, and 4. And I didn't write them in ascending order just because I didn't actually write out the steps in solving these two, but I would have subtracted 4 on both sides here and added 4 on both sides there to get my solutions. All right, let's do the same thing for when x is equal to 0. So it's equal to 0 if 2x minus 6 is 0. And we'll do this one together because it's pretty quick. So in this particular fraction, the expression would be undefined if x were any of these values. Any of those would make the denominator be 0. The numerator would be 0, however, if x were 3. So we've got all these values that would give us unique situations in dealing with that particular expression. So these are concepts that you need to be aware of. But moving forward, what we're going to be doing is simplifying these rational expressions. So we're still going to be applying our knowledge of factoring to help us do that. But in doing that, we're going to want to keep in mind when these expressions are undefined and when they would be equal to 0. So here we're getting to a situation where I'm going to start asking you to try to do some of these on your own, but we'll do the first 1.5 together. So when we're asked to simplify an expression, there's a set of steps that we want to go through, and again, I'll just go through one of them together, and then we'll write out the steps. What we want to do first is factor the numerator as much as possible and the denominator as much as possible before we can actually simplify. So I'm going to rewrite this first fraction as 3x over, and if I factor that denominator, I can take out a GCF of 3, which would leave me with a 2x plus 3. Now it's completely factored. So in simplifying, I'm not doing anything different now than I would be if I had the fraction 6/9. If you wanted to simplify that fraction, you would reduce it. And what you would recognize is that the 6 and the 9 both have a 3 in common. And so I could reduce these two fractions and say 6 divided by 3 is 2 and 9 divided by 3 is 3, and that would leave me with a 2/3. Essentially what we would be doing there is canceling out a 3, which is a factor of both the numerator and the denominator. And that's what I'm going to do here as well. I'm going to cancel those 3's because 3 divided by 3 is 1. And that's going to leave me with x over 2x plus 3. And now that is completely simplified. So our set of steps here is just pretty simple. When simplifying rational expressions, the first thing we want to do is factor both the numerator and the denominator. And the second thing we want to do is divide common factors. And you might want to pause the video and write those two steps down to help you moving forward here. All right, so let's go ahead and start this second example together, and then I'll ask you to finish it on your own. So over here we have 3y minus 3 divided by y squared minus 2y plus 1. So what I'm going to do is factor the numerator using the GCF method. And then I'm going to factor the denominator using the AM method. So I'm looking for two numbers that multiply to +1 and add to -2. So -1 and -1. All right, now I'm going to pause the video and I'm going to ask you to submit your simplified expression. All right, so whichever y minus 1 you choose to cancel, these are common factors. So I can divide y minus 1 by y minus 1. And my final answer here is going to be 3 divided by y minus 1. That is the simplified expression. I'm going to let you do this one here on your own. So the video is going to pause, and I would like you to simplify that rational expression. Now I'm going to do it. So I'm going to factor that numerator. Again, I'm going to use the AM method. So r plus or minus two things that have to multiply to -5 and add to -4. So I'm going to say -5 and +1. That looks like my numerator totally factored. And I can again use the AM method in my denominator. Factors of -15 that add up to 2 would be -5 or to -2 and positive 3. So now I can divide common factors. R minus 5 divided by R minus 5 is 1, and I'm left with R plus 1 divided by R plus 3. When you type that into a computer, you're going to want to put parentheses R plus 1, close parentheses, divided by parentheses R plus 3. And all of those parentheses are going to matter. So just for future reference if you need to type this in somewhere. And let's do this last one. I'm going to ask you to do this one as well. So go ahead, try the final rational expression. All right, now we'll do it together. So first we need to factor both the numerator and the denominator. Again, I can use the AM method in my numerator. Factors of 12 that add up to negative 7. That's going to be m minus 4 and m minus 3. In the denominator, I won't be able to use the AM method, so I'm going to want to use grouping. But first, I'll use the AC method to separate that middle term. So 2m squared. I'm looking for factors of 6 that add up to negative 7. So negative 6 and negative 1. Minus 6m minus 1m plus 3. And then from there, I can rewrite this as 2m times m minus 3 minus 1 times m minus 3. So my factors are 2m minus 1 and m minus 3, and now I can divide common factors. So completely simplified, that's m minus 4 over 2m minus 1. And this is what we're going to be working on here over the next couple of days. This skill will be built into the next 2 lessons. So your next homework assignment will be due on Monday. It'll be a little larger than a normal homework. I'm going to send it out today, but it's going to contain content from our Thursday and Friday lessons, which we haven't done yet. So you may not be able to do all of it just yet. All right. Have a good day, guys.